Standard internal tools for enterprise agents suffer from critical interface bloat. Because these systems act as passive repositories, they force the human brain to serve as the primary processing engine for every data point. In this environment, cognitive load is the specific mental effort required to hold disjointed data in short-term memory while navigating across multiple open tabs. This layout forces extensive context switching and repetitive click paths, creating a measurable latency in agent decision-making. Until the interface itself shares the processing burden, human agents will remain a constraint in enterprise workflows. The solution requires an architectural change, moving the UI from a passive data repository to a proactive workspace. We do this by combining high data density with localized AI microservices and refined UI patterns. This shift alters state management by processing data locally within specific components rather than at the system level. These intelligent nodes intercept and handle raw data before it ever reaches the agent for visual parsing. This allows the agent to move from the role of a manual data gatherer to that of an executive decision maker. Any effective dashboard must optimize how agents scan high-volume information without exceeding their cognitive capacity. Profile cards serve as the foundational layer, providing immediate contextual anchors at the very top of the viewport. Advanced data grids support this by allowing agents to filter and edit records in line, which keeps their focus on a single plane. We can map the life cycle of a ticket chronologically using timeline components, which removes the need to switch tabs to find historical context. Toast notifications and status badges appear within this same frame, maintaining real-time awareness without shifting the layout or disrupting the active viewport. These baseline primitives work together to reduce the friction of initial data ingestion. Establishing these clean, dense data primitives is a necessary step before we can integrate more complex AI functionality. Shifting from ingestion to manipulation reveals the compounding time cost of high click counts in traditional enterprise tools. To solve this, a global command palette allows agents to bypass nested navigation menus using keyboard-driven commands. We also implement standardized quick action button groups for the most common tasks, such as issuing refunds or escalating tickets. Standardizing these groups eliminates the time agents spend hunting through drop-down menus for routine functions. Streamlining these actions connects the interpretation of data directly to the resolution of the customer's problem. The workspace evolves when Gemini AI is embedded directly into these localized UI components, rather than functioning as a separate chat tool. By delegating data processing to the component level, we shift the heavy lifting away from the agent. The AI Summarization Card takes a messy history of support tickets and instantly produces a clean 3-bullet summary. This single component removes the need for an agent to manually read through pages of historical logs. We see the same limitations in standard text inputs, which remain static and offer no assistance during formulation. Smart Compose Textareas upgrade these inputs with real-time, context-aware predictive suggestions. The algorithm adapts to the specific tone and history of the current conversation to assist the agent as they type. Static status markers also present a problem, as they require manual updates and don't account for changing user states. Dynamic sentiment badges solve this by reacting to real-time user metrics, changing visually as Gemini analyzes customer satisfaction levels. By removing the requirement for manual data parsing at each of these steps, the interface becomes a proactive assistant that anticipates agent needs. Engineering teams often view premium consumer-grade UI paradigms as unnecessary for internal tools. However, high-end aesthetics drive spatial memory and focus, providing a functional benefit in dense environments. Customizable bento box dashboards replace rigid one-size-fits-all layouts with a modular grid system. This allows power users to organize their workspace geometry to match their specific daily workflows. We can apply glassmorphism to the command palette to maintain the user's subconscious spatial context while they search. The frosted glass effect blurs the background dashboard, which aggressively minimizes distractions without making the agent feel like they've left their workspace. Gamified success bursts, such as fluid animations, provide essential microfeedback when an agent completes a task. In complex environments, high-end UI polish serves as a mechanism to reduce psychological friction and sustain agent engagement. When we zoom out, we can see how these individual components form a cohesive, proactive system. This map shows the data flow. User input triggers a central AI process, which then automatically updates the localized widgets across the bento grid. These systems work concurrently, ensuring that the interface remains responsive without overwhelming the agent. This combination of baseline density, keyboard-driven action, and embedded AI helps reduce enterprise error rates. Ultimately, the success of a component library is measured by its ability to systematically eliminate friction from human-computer interaction. The final requirement for this architecture is raw system performance and rendering speed. Executing dynamic AI updates and advanced visual effects requires highly optimized state management. This makes the choice of front-end framework, like React, Vue, or Svelte, critical for rendering these dense component updates efficiently. Building a proactive workspace requires aligning these high-level design goals with a precise technical execution.